So today we are going to look at a case study of a building, or actually multiple houses that are built using a straw bale construction on the exterior wall. They are using it as partly as a load-bearing material, but particularly as an insulating material. You've probably heard about straw bale houses before, and it always sounds a bit like, oh, is that even safe? Does it hold up? Is it safe when there's a fire with water? Are there like little critters and animals and insects and all of it living in it all of a sudden? And I will touch on some of those frequent questions at the end of the video, but I briefly want to give you an overview about the project first and really reiterate that with any construction principle, it really comes down to proper execution. It's really important that things are manufactured and assembled in the way that they are supposed to be, in a safe and proper way, and then all these concerns are not that big of a deal actually. Just a reminder as well, this might be a little bit of a longer video again. Use a timestamp in the timeline to skip back and forth as you need. I'm doing my best to highlight the important bits and address some of the concerns or questions that you might have, and you can jump in. The project that I want to introduce here is a multi-unit residential project outside the city of Zurich. It is basically a low-tech passive house design, so that means they are using very little technology in the building, trying to really reduce operational energy expenditure in that sense. And it's a Swiss office that built it. They've built over 60 straw houses across the country already, and this is one of their largest residential projects. And they really have become experts into using straw bales as a material. This particular project features 28 units across 5 different houses, and they have mixed type apartments as well. So they are ranging from 1 to 4 bedroom apartments, so therefore sort of allowing different demographics to move into this project as well. So it's not just sustainable from an environmental, energetic point, but it's also sustainable from a social, cultural aspect as well, which I think is really important to look at these things holistically. The entire building has used 420 metric tons of straw, and that sort of equates to a harvest of a field that would be the size of 105 hectares. And many of those panels have been prefabricated in a workshop and then brought onto the site. So these exterior wall modules come in a pre-assembled way, and they're put together, and it only took them 5 weeks per house, so 5 houses, 5 weeks per house, to actually assemble and put those structures together. So it's a super efficient way of assembling, which means you're saving a lot of time on the construction place, and it makes it less weather dependent when you're actually building and constructing those houses as well. And what is really, really important as well, and I want to note, is that it is designed for disassembly. So that means the straw bales and the construction has not used any adhesives or bonding materials. At the end of the lifetime of these buildings, let's assume hopefully they will last 50 years, they can probably last 100 years, but that is not just dependent on the materials, but also on how people treat and people's expectations of houses and living situations and all of that. So at the end of the lifetime of those houses, you can remove the straw again without it being contaminated with any other materials. So that means the material, the straw, is in its pure form, and it can just be recycled at the end of its lifespan. It's not going to go to any landfill, or it's not going to be any toxic waste, what we would see with many insulating products that are made out of plastics or some sort of plastic derivatives. So that is a massive, massive advantage. On top of all of that, straw is a very cheap material because it is left in its natural state. It is so easily recyclable. And then one point to note as well, there is not a lot of grey energy in the production of those straw bales. So what does that mean? If you have some sort of an insulating material that is made out of a plastic material, or that maybe glass wool that uses glass, all those materials use a lot of energy in their production phases. So there's a lot of grey energy, as we call it, that goes into those products. And once you assemble them on a construction place as well, they usually use a lot of adhesives to attach them to a construction. So that means they are really difficult to recycle, and they use so much energy already that even though that in the lifespan of your house you are saving energy because you are lowering the operational costs because you have a good insulation, so you're decreasing the need for heating or cooling or whatever that's required, but that's sort of negated a bit because you put so much energy upfront into producing the materials themselves. So these sort of calculations have to go into the considerations of the entire lifespan of a building. And that's where straw, it has a massive advantage because the grey energy amount is so much smaller. It's the harvesting, it's the transportation, of course, but it's a very natural material. So, and last but not least, of course, straw has a really good thermal insulation coefficient, so that means it is an excellent insulator. It's one of those construction principles that's been tried and tested throughout the last centuries. If you look back at the mid-19th century and the beginning of the 20th century, straw bale houses have been around for a long time, and we've sort of forgotten about these construction techniques in the meantime. Now let's have a closer look at the detail, and I want to preface this with having a brief look at the ground plan as well. What you will notice immediately is that the individual houses are very compact. They have a very simple shape. They don't have many corners and crevices. This again sort of makes the whole process of assembly and prefabrication much more efficient. But at the same time, it also means that the ratio between volume of your building and the surface around it, so the facade, is optimized. So you have the maximum amount of volume and the least amount of facade. Because your external walls, the facade, that's where thermal conductivity, where heat loss or cooling loss is happening. And obviously you want to keep your houses as compact as possible. That means you need as little heating or cooling inside the building to feel comfortable. Let's have a look at the facade section of this particular building. One thing that you probably immediately notice is just the thickness and the width of those exterior walls that we can see here. The architects state that the walls are 75 centimeters in width. I'm not quite sure if that includes only the straw bales, so this measurement, or the internal construction as well, but nonetheless that's one of the kind of side effects, and I'll touch on that in a bit as well, of straw bales, because they need quite a significant thickness to work as they are intended. So what you'll notice as well, and I'll zoom in a little bit, is that on the inside we do have a cross-laminated timber panels, I must say. That's the word that I was looking for. And then the straw bales are attached or stacked up and infilled on the outside. So technically those straw bales, you could manufacture them and assemble them in a way that they become the single load-bearing material for that construction. The architects say that they had an issue of getting the proper paperwork and like doing the research that backs it up. So that's why they went for a cross-laminated timber panel construction on the inside, which is roughly, I think it's about 100 millimeters, 10 centimeters. And then there's a gypsum board on the inside here as well. And then as a last sort of finish, there is a lime render on that side. On the outside, we do have, this is number 5 here, quickly scrolling down, whoops. Oh, it's not outlined here, but yeah, that is a render as well. On the outside, protecting and sort of sealing in the straw bales, making sure that they are waterproof, nothing can crawl into it, and they are really sealed off. So again, that's the entire build-up of those exterior walls, which is really interesting to see how little materials that you need. Of course, that kind of width of the construction comes sort of at a price. So if you have a very limited space on your plot, on your site, that means that you are actually losing some of the square footage of your building that you can occupy just because of the construction. So your interior may get a little bit smaller. But let me reassure you, given that this project has been built in Switzerland and we do not have a lot of space in Switzerland. It's a tiny country, a lot of people are highly densely urbanized. And if they manage to do it, most countries will be able to do it. And I did a quite nice little detail here, and I'll show a photo on the screen as well. That's of course, the window. You can see the window frames. It's triple glazing. It's attached again to these CLT panels that sort of form a frame, which means the windows are structurally attached to the main load-bearing layer, which is these like slightly thicker CLT walls, and they attach the windows a bit more on the outside, which means that here, and I'll quickly switch to another color, here we have a sort of a space for people to sit on, a little alcove or a niche, which is a spatial element that provides a lot of interior quality. And I also did a really nice like inbuilt shelving unit on the bottom here, so you can stack things, you can use that as storage, you can sit up here, you can read your book, and you can look outside the window. So I think it's a very obviously not an unusual construction. We've seen that many times in other projects as well, but it's a really good utilization of that space, and it enhances the character of the building. And of course, that kind of width or the thickness of those exterior walls, it will be visible on the outside as well. Just have a look at some of the photographs, and you can see how the architects play with it. It's almost like a bracket or a framing of the house that they use to show that. Of course, you also see a couple of details showing a structuring of the facade. On the one hand, it provides a little bit of a rhythm on the facade, so it's not just one homogeneous material on the outside, but it structures it. And of course, there's a smart way. If that render here on the outside would just go through as normal, you potentially have an issue of little cracks appearing in these points, because on the inside you would have moments where you have the straw bales, and then you have moments where there is a slightly different construction, and that change of material on the surface of where the plaster is attached to can potentially lead to little cracks, because those materials, they will expand and move differently based on especially when they get warm or when they cool down again, they move a little bit. We know that materials expand based on temperature, and these expansions are different based on what material it is. So you would have different kind of movements here, and that leads to little cracks because there's a little tension happening. So what the architects did here, and let me erase some of that stuff. I'm going to get a slightly bigger, there we go. Nice clean canvas again. So what they did here is that they provided a little timber element that's protected with what I assume is a metal ledge. So making sure, and we know that if there's rain coming here, that will drop off and it drips off away from our construction. And that raises another point. Oops, if we are zooming out a little bit again, you can see that the roof has a little bit of an overhang. Not much, might only be about, I would say, 25 centimeters probably. And that is providing a lot of protection for the facade as well. The render on the outside, it's allowed to get wet, that's perfectly fine. But of course, if you can limit that to a certain degree, the better. Because if these bits are always like getting humid too much, you can have you can see aging much faster. It could lead to growth of certain algae or mosses and things. So keeping your facade as dry as possible is always a good idea. What is quite interesting as well is that they decided to use the same sort of construction in the roof as well as they use on the exterior walls. So on the one hand, that simplifies all of it because it is the same technique. It's just in an incline, on a slope. It also means that the thermal conductivity here will be roughly the same as with the exterior walls. So both of them would have really good what we call U values, or sometimes you see them as R values, so they are defined slightly differently, but they mean the same thing. They mean, both of these values determine how fast or how slow actually heat is going from the inside to the outside. Or of course, if you're in a climate where you need cooling, it's about how much of that cold you can keep on the inside to make it comfortable. There's a very conventional roof covering, so there are some sort of rafters in here. There's probably an air gap for air to flow through, and then rather than having a conventional sort of roof tiles here, they specifically added PV systems, so a photovoltaic, a solar panel system onto the roof, which means they are actually generating the energy for the building themselves. I need to double check, and you can see that in the project documentation as well. They state how much energy that they are actually producing and how much that covers. Quite often it covers heating your warm water. Sometimes it might even cover for more electricity needs in your building. You probably noticed, and I'll quickly zoom over here to the photo as well. It's a very high-pitched roof, and it's actually multiple of those units together. So they form a very special detail here in the middle with the roof coming together, and that's I would say it's a tricky detail. You have to be quite careful, and you have to detail it really, really properly, because you can imagine if water is coming from both sides, the rainwater, and it's collecting in here, you want to make sure that, and we'll go into the detail over here now, that the water is not just building up, but it actually flows off to maybe both sides or either of the sides. We can see here in the photo there is definitely some sort of water management leading the water from the roof down to the sewage system. But of course, if this is not done properly, you risk of water being stagnant in that place and then eventually seeping into your construction uncontrollably. So this is absolutely something we want to be really careful about and do properly. Another thing I quickly want to mention, which I think is quite interesting, I was talking about those CLT panels on the outside with the gypsum board and the plaster, and they use the same thing on the interior. This bit here is kind of the interior wall of apartment 1, and then you have the interior wall of the apartment adjacent to it, so that will be your neighbor, and then in between we have a bit of insulation as well. This is just helping to soundproof the two units even more. This is something to be quite careful about in housing projects where you have multiple people or multiple families living in one place. You want to make sure that the soundproofing is done properly, because timber is not as heavy of a material as concrete. It has usually less of an ability of absorbing sound and sound waves. So this is really an important detail to pay attention to. And the same thing is happening here on the floor construction. So the floor is made up of a CLT panel as well, which connects to the exterior walls. And then on top of it, we have, let's just call it a crushed stone fill. And then above it, you have a soundproofing layer of insulation. There is a layer of a separation layer. There's a concrete screed, which includes the underfloor heating, and on top of it is your floor finishing, which in that case is a wooden timber floors. This stone filling here again provides additional weight for this entire construction, because one of the issues is when you have people up here, they're walking around. You've probably heard that from your neighbors above if you live in an apartment. You can hear all their steps on in the unit downstairs, because that whole package sort of vibrates. It's almost like a musical instrument. The whole thing is moving with those steps, and the sound is transported into the unit below. One way to reduce that is to include insulations, which they have. So this is a insulation that helps to absorb some of those noises, the steps, but also the heaviness of that element as well. It helps that the element is not moving and therefore not transporting the noise as much. Particularly in timber constructions, this is really, really important to pay attention. And you can see here as well the connection of how the floor plates are connected to the exterior walls. It has an impact on how the whole element looks over here. That's why they did that little trick on the outside as well. What we don't see in this building section, but we can kind of see it a little bit when we zoom into the photo, is how does it connect to the soil. And it looks like they have done some sort of a plinth detail, because again, when we zoom in here, they conveniently just stop at this point. But as we talked about in other videos, if there's some sort of a plinth and we have the ground coming here with the grass or gravel or whatever it is, you want to make sure that you don't have rainwater splashing onto that plaster and then it's just constantly wet. So this is something that we definitely want to avoid, not just with this kind of construction, but in general. Yeah, they do have exterior sun shading as well. And again, I mentioned it, there's a little overhang for the roof with the gutter being on the outside. This as well, it means that the water from the roof will run off, it will be collected in the gutter, and then it goes into a pipe down into the sewage system. You probably have seen these slightly hidden gutter systems as well. They are, sometimes people think they're aesthetically a bit more pleasing. They do have a risk of, it is more difficult to access them if they're built in, and it's more difficult to see if there's any issues with water accumulating within them and not flowing off properly. So if they are exposed as they are here, it actually is much easier to detect any issues, and also replacing them if something breaks. I did a little mistake. Of course, the rainwater pipes would be assembled more like this. So obviously the water will go back to the facade, and then they are go down. So this is some of the main details and sort of construction principles that we can see in this particular section. Of course, they paid the most attention to this building envelope sort of layer, and then some of the other details, I would say the plinth detail, the roof detail, these kind of gutted details, whoops, there we go. They are a bit more standard details that you would find in other places as well. And that's always a kind of, you don't want to, as I said before, you don't want to reinvent the wheel all the time, but it's a bit of a mix of different things. And so last but not least, I want to touch on a couple of questions that come up quite often. And I'm happy to do a bit more of an in-depth research video about this if you're interested. So many people are kind of concerned about straw bales, and if you hear straw bales, it's like, oh my God, what if they catch on fire? Is it going to be the entire city going to burn down? Because if you think about straw and fire, you see a big bonfire. And let me reassure you, and you can see that in the example that we just talked about, it is in a quite urbanized area. There's lots of buildings next to each other, and they didn't have any issues with getting a building permit based on the fire safety of this particular building. They tested the straw bale constructions. They have if you are from a German sort of speaking context, what they call an F90 rating. So that means the construction will be safe if it's burning in the house for more 90 minutes. And this is actually the equivalent concrete wall with a width of 25 centimeters would have as well. They would have the same fire rating as well. And you have to understand fire ratings. If there is a major fire event, all buildings will have, regardless of their construction, they will all have massive damage to the point that they may not be saved at the end of the day. But what we are trying to do with construction is to keep them safe and stable for as long as it takes for people and animals and everyone else to safely evacuate from the building, and preventing the spreading of fire to other buildings in its neighborhood. So that's how that mechanism works. If there is a major fire, any building will burn. And there's a bit of an unintuitive thing sometimes. People are like, oh, steel is, it's a super tough material. But steel will melt. And steel is actually more dangerous in that context than a timber building, for instance. If you have a timber frame building, and if the timber has a big enough dimension, it will burn a little bit, it will char on the outside, but the charring will actually then prevent the timber from burning even more, and it will be more stable than a steel or an iron building, where if that material gets hot, it melts, and that provides issues for the stability of that building. So fire is not that big of a concern, again, if the construction is manufactured in a safe way. So that means the render on the outside needs to be properly attached, and the straw, because it's compacted, has to meet certain requirements as well. Another big concern that often comes up is about whether those buildings are actually stable enough to be used as a load-bearing layer, and in general they are. And I mentioned it before with that particular case studies that there was a bit of a time constraint of getting all the paperwork done and showing to the council that this is enough. But there's many examples where we can see that they have very high load-bearing capabilities. And then, of course, one of the very important things about construction is water management. People are slightly concerned that it could get moldy. What happens if the straw is soaking up water? And this is exactly the same as for any other construction as well. You want to make sure that your materials are protected from any kind of water, whether that's water from the outside, from rain, or if you have a big kind of spill in your bathroom and your bathtub is overflowing and the water is inside, or it could be the humidity and the vapor. As long as it's done properly and again it is sealed off, none of that water should be able to penetrate and go into the straw bales, and so you don't have to worry about any sort of mold growing in that material. It's also safe for people that might have some sort of allergies. There might be a little bit of an issue during the construction phase because you do have some particles flowing in the air, so that could be a little bit of an allergy. But once it's all finished and the construction is done, there's no adverse effect from that construction. And then last but not least, I've heard that a lot as well, that people think there could be mice or insects and bugs and anything living in that kind of material, because again we have that association of straw bales as we see them in a farm. They are not these loosely kind of straw bales, they are highly compacted. So any bigger animals such as rodents or mice, they cannot get into that material. They are not going to burrow or build their nests in that material. They usually cannot even penetrate the plaster on the outside. And then same for bugs and everything. They do not prefer that kind of environment. Even termites are said to not like these kind of straw bales. So unless you have a massive issue in how it's assembled, you won't have a problem with any critters living in your facade. So hopefully that was helpful, and address some of the issues that you might have. Of course, there's a huge amount of research on that topic, and just let me know in the comments as well if you'd like to hear more about all of this. I might have to do some additional research myself, but I'm very interested into diving deeper into these topics as well. So thank you for listening. It's been a long one today, but hope it was helpful for any of your projects coming up. Thank you.